Today I want to show you the ESP32 file manager. It's a simple but surprisingly capable way to work with files on a very limited hardware. For this prototype I'm using an ESP32S3 and I'm deliberately not relying on PSRAM. About half a megabyte of RAM is enough. The display is an ILI 9341 with an XPT2046 touch controller connected over SPI. The microSD card is a standard FAT32 card, also on SPI. The display and touch controller share the same SPI bus, while the SD card sits on a separate SPI bus to keep things stable and reliable. Also, what I've seen in the ESP-IDF is that usually when you have an SD card with other devices on the bus, you want to configure it first and then the other devices. To power everything up, I'm using a 12-volt car battery feeding a DC step-down converter, which then powers the breadboard power supply. From there I have two rails, 5 volts to power all the modules and 3.3 volts used for pull-ups on the chip select lines for each SPI device. Everything pulled up on 10K resistors. For stable connections and clean signals, I grounded the ESP32 using multiple ground pins. On the very first boot, there is no safe touch calibration, so the device automatically enters the calibration screen and shows a short calibration message. The idea here is to press right in that center, so the screen gets calibrated successfully. After the last step, the calibration is saved to memory and you can just start using the interface normally. So the main reason the system can handle very large folders is the way items are loaded. Directories with lots of entries don't overwhelm memory because the list is paged. Instead of loading everything into RAM, only a fixed size portion of the directory is kept in memory and new items are loaded dynamically as you scroll. This is not applicable for this folder because we have a small number of items, but for example, if we go to a very large folder with more than 600 items, we can see that the items are getting loaded incrementally, and this slider over here is showing the overall position in the big folder. For example, we can drag this even to the end of the folder, and as we see here, we get to the end of it. A very similar approach is applied on the big text files. For example, this one is 34 kilobytes, and as you can see, we are loading it pretty quickly as we scroll. We also have here this big slider that lets us go directly to a certain portion of the file and loading it pretty quickly. This is very quick because it is loading only 1 kilobyte from the text file at a time, so this is not much work for the ESP32. In the case we're trying to edit files, so if we go back to this file and hit edit, let's say we want to edit the first 1 kilobyte of this file, and we're trying to load the next page. Over here we can see a message box telling us that we either have to save or to discard the changes. So in this way the changes remain pretty safe when we're trying to navigate over the file. Also, I think this is a very good opportunity to show you this way of loading the pages. For example, let's look at this line that says edit file done or save file done. And if you're actually loading the next page, we're gonna have the scroll right back where we were, and in this way the file is pretty consistent, so we don't have too much jagged changes. For the image support in this version of the file manager, currently it supports only basic style JPEGs. So PNGs and other image styles are not supported. And JPEGs need to be maximum 8 times the resolution of this screen. The system was designed to handle SD card problems really well. So, for example, if we try to remove the SD card while we try to perform any operation on the file system, we will get this type of warning asking us to reconnect the SD card. And after we do, the operation is completed. For example, if we're trying to edit a text file, let's say we want to add a line over here, and we take out the SD card, trying to save it, get the same prompt again, asking us to reconnect the SD card. The connection needs to be well, and the text is saved. The same principle we have when we trying to load the pages. So for example, we try to load a page with the SD out. We get the prompt, reconnect the SD card with the right connection. Oh yeah, so if the connection fails, the system will just restart. So let's try that again, hoping that the connections are good enough. For breadboards, usually this is not the case. Let's hope this time will, yeah. And after reconnecting it, we can see the next page. The next thing I want to show you is the settings. So we have a reasonable number of settings here. I won't go through all of them, but in my opinion, the most important ones are the brightness. So we can go from 1 to 100. The screensaver and the Wi-Fi and SNTP connection for time. Also, we have some toggles for calibration at startup and on auto connection at startup for the time. The reason I'm saying the screensaver is one of the most important ones is because of this off-screen option. On the screensaver, we have dimming. Let's set it after 3 seconds to 25%, and let's say screen off is after 6 seconds. After reapply, we will have some fading to dimming and also to screen off. And when the screen is off, the whole system gets to light sleep, or the ESP32 gets to light sleep, and current gets really, really low. The last thing I want to show you before we finish with the power consumption is the Wi-Fi and SNTP setting. So we can auto connect every time at the restart or do an instant refresh. If we hit this, we'll get an error because we haven't set our access point yet. And we can also do this from here if the time is not set. We can also do it manually, so we don't need necessarily Wi-Fi for time, but I suggest doing it this way. So let's complete this one. The settings are applied and we can restart it to refresh. Time set successfully, and we should see the time right over there. And yeah, the time is pretty consistent. What I wanted to show you now is the actual power consumption of the system. So usually when we are at idle with full brightness, we have around 110 milliamps. But we can see that the current drastically changes with the luminosity of the screen, remaining at around 55 milliamps if the system is still powered up. And if the system is sleeping, so if we turn on the screensaver, we'll see a drastic reduction in current. So from 110 to around 16 milliamps. And the 16 milliamps we see here is not necessarily because of the ESP32 module, is because the components of the dev board that the model is on. So the biggest current eaters for this and usually all the dev boards is this USB to UART converter, which it's around 5 to 15 milliamps, this always on LED, and the LDO. So usually if we would have an alone module with all the other components, we would see around maybe 3 milliamps.